All right, let's look at our fourth week of quick quads here. So question 1 says we have a chord that is 24 inches long, 5 inches from the center of the circle as shown below. What is the radius of the circle to the nearest tenth of an inch? So remember, a chord is not the diameter, it's not go through the center of the circle. So we've got the center here, but this whole length of the chord here is 24, so we can go ahead and assume that this is half of the 24, so that's 12. We need this radius right here is the center going to the outer part of the circle. So what we got here is we have a nice little triangle. We've got a right angle here, so this looks set to be perfect for the Pythagorean theorem. So remember, a squared plus b squared is equal to c squared. Remember, the c is the hypotenuse, or the side opposite of the right angle, so that's going to be our radius. 5 squared is 25, plus 12 squared is 144, is equal to our r squared. 25 plus 144 is 169. Is equal to the r squared. To get rid of that r squared, we're going to square root both sides, and the square root of 169 is 13. So it looks like our answer there will be D. Number 2, the length L in meters of a spring is given by the equation L is 2/3 of F plus 0.03, where F is the applied force in newtons. What force in newtons must be applied for the spring's length to be 0.18 meters? So we've got two variables here. We've got an L and an F. F is our force, while it says the spring's length is 0.18. So we can go ahead and substitute that 0.18 in for L. There's really not a lot of room there, so I'm going to flip this over to the back. So 0.18 is equal to 2/3 of the force plus what? Plus 0.03. All right, so all it wants is to solve for F. We need to know how much force we need for this spring to be at 0.18. Whatever formula this comes from, so we're going to subtract the 0.03. That's going to leave me with 0.15 is equal to the 2/3 of F. Now, to get rid of that fraction, all we have to do is multiply by reciprocal. And go ahead, I would put this in your calculator. When I put 3/2 times 0.15 in my calculator, it tells me 0.225. So I'm going to flip our answers over, and it looks like letter C gives us the 0.225. Cool. Number 3, after a snowstorm, city workers removed an estimated 10,000 cubic yards of snow from the downtown area. If this snow were to be spread in an even layer over the entire rectangular football field shown below, how many yards deep would the layer be shown? Or how much would the layer of snow be? So it's talking about a cubic yard, so we have 3 units of measure here. It gives us a length, it gives us a width, and it wants to know how deep something is. So this kind of indicates to me that this is a volume type question. You know, we want to know how much stuff is kind of packed into the snow on top of the football field. And volume, remember, is 3 units of measure. It's length, width, and the height. So the height is going to insinuate the depth of the snow. Well, the length, so a football field is 100 yards, but we've got 10 yards of end zone. So the length is 120 yards. The width of the football field is 53.5 yards. We don't know H, right? We don't know that depth. That's what it's asking us for. How deep would the snow be? But we know the actual volume of how much snow we really have, right? It told you in the beginning that the city workers pulled out 10,000 yards of snow. So that 10,000 yards is now being dumped evenly over the football field. So that is our total amount of volume. We can't add snow that just because we moved it somewhere. All right, so again, we've got our 3 units of measure here. We've got length, width, height. All of that has to multiply out to be 10,000. And, we've got an equation here. We've got a variable we need to solve. So 120 times 53.5 gives us 6420. So there's really not enough room. 6420 h, right? We need that height, we need that depth there, is equal to the 10,000. And this is stuck by multiplication, so we're just going to go ahead and divide this off. So 10,000 over the 6420 is 1.55. Okay, so about 1.5. And it wants to know about how many yards deep will the layer of snow be? Less than 1 yard, between 1 and 2. Well, we just got an answer of 1.55, so that's 1.5. 1.5 definitely is between 1 and 2 there. All right, and number 4. The hypotenuse of the right triangle PQR shown below is 16 feet. The sine of angle P, okay, this little guy, I guess, is going to insinuate angle P. So it's giving us this right here. Angle P is 3/5. About how many feet long is QR? So we want this guy down here. It gave us the sine. Well, remember sine from geometry class is opposite over hypotenuse. Remember, opposite is, what you can see opposite of it, adjacent, what would be next to you. Hypotenuse is the opposite of the right angle. So in this particular instance, we're going to say, well, we don't know what the opposite is. That's our unknown, but the hypotenuse is 16. But they gave you another part of the ratio here. They told you what it simplified out to be. The sine of angle P is 3/5. Right? So we know the relationship of sine is opposite over hypotenuse. Hypotenuse, the triangle that is given, is x over 16. But the actual ratio that we see there is 3/5. We can solve this proportion through cross multiplication, or one thing I like to an easier way to maybe think about it is what's the relationship or what's the unit rate going from one fraction to the other. So the way to kind of find out that unit rate, I'm going to do 16 over 5. So it's 3.2. The unit rate to go from, the simplified form is 3.2. So all we've got to do is take that 3, multiply by 3.2. Kind of just saves you an extra step from having to do the cross multiplication stuff. So it looks like x is 9.6, and it looks like that's what we have for letter B there. Okay.